Dear students, welcome to the discussion class on logical implication which deals with the rules of inference. In fact, this is the actual topic where the logic is being used now, where we will be given some arguments and we'll identify whether these arguments will lead to some conclusion. So that's the concept what we discuss here. Very interesting topic. So hope you will find it very useful. So rules of inference are a set of axioms or statements that enable us to conclude if the given argument or set of arguments are valid or not. So using the given arguments or using the given set of arguments, we are going to check whether they can give some conclusion. So to arrive at a conclusion, we use some set of rules, and those rules are called as the rules of inference. And rules of inference are actually fundamental in the development of a step-by-step validation of the conclusion. We will see how that is being done. So before we go to the rules of inference, let us consider two important topics. One, the logical equivalence, and the other related jargon with respect to the implication. The first one, consider P and Q are arbitrary statements such that P implies Q. Hope you remember that P conditional Q we have discussed earlier. So P implies Q is a tautology. Then we say that P logically implies Q. So here I draw your attention to those various lines of representation. The single arrow which we are using here is implies, we know that, and we have used another arrow where both the ends are closed, which is called as a biconditional, okay, or bidirectional. Then we have also seen something of this category which we used as a logical equivalence. Now we are considering something new, which is like this, which is only equal operator one side, that angle bracket, which is logically implies. So without any confusion, so get the clarity between these three or four operators. Okay, so this is logically implies. So what is logical implies now? If we have a implication from P to Q and that implication is a tautology, then we say that P logically implies Q. So we'll see some of the examples, but understand logically implies is also something available in this, and that is different from the various symbols what we have used now. So before we go to the rules of inference, so consider this now. Understand there are premises or statements like P1, P2, P3 and Pn. So n number of arguments or statements are there, and they lead at the end to Q, where Q is the conclusion. So look at the concept here. So P1 and symbol, P2 and symbol, P3 and symbol. So consider a court, let us say. A lawyer is arguing. So all the arguments a lawyer is arguing will be used. That means and. If a lawyer speaks on 3-4 points, all the 4 points will be used by the judge or whoever it is to come to a conclusion. So like manner, all these arguments, say P1, P2, P3, Pn, they all will be added together. That's why it is a AND operator. And at the end we come to the conclusion called as a Q, whether we can do this or not, whatever it is. We'll see some of the examples. So if that can be done, probably we say that all these P1, P2, P3, P up to Pn are going to be premises or the basis statements or arguments, whereas Q, which arrives after this discussion of arguments, then is called as a conclusion. So this is the concept of an argument and a conclusion. So this is what we are going to get through the rules of inference. So for example, consider a statement: if it rains, I will get wet. This is one statement, one argument. If it rains, I will get wet. One more statement is given: it's raining. So using these two statements, somebody is concluding that I will get wet. So please observe how this is done. So one statement is given: if it rains, I will get wet. That is one argument. It's raining, second argument. Both clubbed together, this and this, you are going to get conclusion. You can see the therefore symbol. This is what being used as a conclusion. Whatever you see after this line with the therefore symbol is going to be called as a conclusion. So here two statements are given, and these statements, if we represent logically, consider it rains as R, I will get wet as a W. So if it rains, then I will get wet. So it is obviously a conditional statement. R implies W. It is raining, that is nothing but a basis premises called R. Therefore, I am going to get wet, which is going to be W. So here, as per the rules of inference concept is concerned, these two statements, that is R implies W and R, are two arguments. So if at all you represent them in the form of what they call logical implication or logical implies, this is how we are going to represent. So R implies Q, W is one statement, and just now we have discussed that all arguments are ANDed together, and R. These two arguments put together will give a conclusion called W. So here we say that R implies W and R logically implies or gives some input to W, so that this and this are logical implies. That means RW and R are the logical implication towards W, provided this is going to be a tautology. So that's what the meaning, what definition, what you have seen. So don't worry too much now. What we have to keep in mind is we are going to prove whether the given arguments are going to lead to a conclusion or not. For that purpose, we will be using rules of inference. How? We will be looking shortly. But what you have to keep in mind here is all the arguments are going to participate together, and hence it is a AND symbol, not OR symbol. Every argument has a role to play, and hence it is a AND symbol. Okay. Now, consider the following truth table. So, P, Q, negation P, negation Q, P implies Q. We know how P implies Q is arrived. Whenever P is that is true, Q is false, it will be false. In all the other cases, it is going to be true. Now, we are going to get these two equations or expressions rather. P implies Q and negation P. This is what the outcome we have, truth table. Next is negation, P implies Q and negation P implies negation P. Since there is no space, I have used it again as 1. So that gives truth table. So what we are proving now? P implies Q and negation P implies negation P, which is going to be tautology here. So as per the definition of logical implication, if I can have P implies Q, which is a tautology, then I say P and Q are logically implies. That's what we have written here. So P implies Q and negation P logically implies with negation P, because the implication of these two is a tautology. So that is what the definition we have written there. For your just understanding, this truth table has been considered. Now let us take one more truth table here. So where we would like to know P and Q are R as 1. Second, P and Q are R. So between these two, if I find an implication and if I can prove that the outcome, the end result is a tautology, I can easily say P and Q are R implies P and Q are R is a tautology, then P and Q are R is logically implied to P and Q are R. That's what we have written at the bottom. So this is the result. So to get this, what we have to prove now? Take two what we call premises or statements. Take the implication of that. Prove the end result is a tautology. If that is the case, we can say P and Q are the logical implication of each other. So that is the concept. So an argument said to be valid, because our our requirement in this rules of inference is to prove the given set of arguments are valid or not. We say that an argument is valid only if the premises logically lead to the conclusion. If the arguments are not giving any room for the conclusion to be valid or not, then probably those arguments we can say are not going to be right arguments, because there are cases in the court where a particular lawyer might fail. Maybe because the arguments what the lawyer is putting forth may not be up to the mark or not relevant to the particular case, then probably that particular lawyer might be failing to get the judgment in his or her favor. Similar to that, if any argument what we are going to get here, if they cannot be logically leading, please remember the word logically leading to the conclusion, then we can say that those particular argument or arguments are going to be not valid. So for an argument to be eligible to become a valid, they should be logically leading to the conclusion. So if there is no argument which is a properly laid or properly used or properly stated, then probably the conclusion cannot be given logically. So that is the idea behind validity. So now, as I said, two things what you have to consider before we go to rules of reference. One is logical implication. The second one is the converse, inverse and contrapositive of the logical implication, because this concept is very important, and while proving the our arguments to be valid or invalid, we might reuse some of the equivalents here or some of the logical equivalents what we see here. So consider a conditional. See, these converse, inverse, contrapositive are applied only for a implication, that is a conditional. So consider a conditional P implies Q. So the converse or the converse of P implies Q is reversed. So replace P by Q, Q by P, you will get a converse of it. Similarly, the inverse, as whenever you see inverse, you should remember about the negation. So inverse of P implies Q is nothing but simply putting negation in front of the both the premises. That is, negation P implies negation Q is going to be called as a inverse of P implies Q. Then contrapositive. Whatever the converse we have seen, put the negation for that. That will be like inverse of that. We will be getting contrapositive. That means negation Q implies negation P. Okay. So why we are talking about this is, look at the truth table here, that gives very interesting result for us. So consider a two variable truth table PQ. So at the end we have given some of the truth values for P to Q. If you observe, whatever the truth value we have got for P to Q is same as the truth value what you have got for the negation Q and negation. The negation Q implies negation P. What do you mean by this now? So when I have an implication P to Q, it's contrapositive. What is negation Q to negation P? Is a contrapositive. So an implication and its contrapositive are both one and the same. That logically proves a P implies Q can give us negation Q implies negation P, which is a contrapositive, and we will be using this particular expression in our logical validity. Similarly, consider this Q implies P, and I will take another pen. Q implies P, negation P implies negation Q, and the truth tables of these two are one and the same. That means if you take a converse of a given implication, its converse and inverse also one and the same, thereby we can prove these two. That's what is being written here. So by observing the truth table, we can conclude that an implication is logically equivalent here to its contrapositive, and a converse is logically equivalent to inverse. So in this case, this last one is something which we are going to use very frequently. So I suggest you to remember this. That is, P to Q, or P implies Q, can be replaced using negation Q implies negation P, which is precisely contrapositive of it. So having said these fundamentals of a logical implication and inverse, converse and contrapositive, so now the actual topic of rules of inference we are going to enter. So don't be worried about the English names here, because they have been taken from Latin. So but understand the concept so that it will be easy for you to solve the problems and conclude whether the given statement is valid or not. So I divide this table into three columns. One is the rule of reference, because in the exam they might ask you like laws of logic, explain the various rules of inference that can be used to conclude whether the given argument is valid or not. So this table should be able to help you. So rules of inference and related logic implication. So why the second column is important for you is, just now we have concluded that every argument is going to be considered while coming to a conclusion, if the valid conclusion is arrived or not, and hence it is a and symbol that we are going to give. So that's the reason why we have written. And second, we also know that we have a tautology, or the logical connection between the statements or arguments that participate in the validity of a statement. So to represent that, this particular logical representation is given just only for understanding. So the last column is important, that is the name. So as we did in the laws of logic, we have used commutative law, we have used associative law, we have used distributive law, we have used De Morgan's law, we have used idempotent law. Like that, whenever we solved a logical equation, like in digital electronics, so we have represented or just mentioned the name, which rule is being applied. Similar to that, when you solve a problems on rules of reference, on rules of inference, there also you should be able to write the name, that is what name of the rule of inference is being used. So in that case, you should also have the names of them. So that is the reason why the third column is given. So first and third column is something which you have to keep in mind. So first one is modus ponens. So as the name, as I said, it is taken from Latin. So these names may not be comfortable for us, but you should be able to understand the concept and give some connection. So modus ponens, in English it is affirmation. So for your convenience, it is called as a affirmation, meaning that I have a statement P, I have a statement P, I have another statement P implies Q. I have a statement P or argument or premises, the another argument which says P implies Q. When these two are true, when P and P implies Q are true, I can conclude that Q is also true. So this is simply based on your what is called conditional truth table. So when P is true and P implies Q is true, obviously Q is also going to be true. So that is a conclusion. This is called as a modus ponens. Okay. Next, second one, modus tollens. That is a reverse of it almost, which has some negation into that. So I know that I have a P implies Q, I have a P implies Q, and at the same time negation Q is also true. So P implies Q is true, negation Q is true, then obviously I will be getting negation P. Just now we have seen P implies Q is logically equivalent to what? It's contrapositive. So what is contrapositive? For P implies Q, contrapositive is negation Q implies negation P. So now if you take P implies Q has negation Q, then what is left now? Negation P. So remember in that fashion, so that it will be easy for you. That is called as a modus tollens. So modus tollens is based on the contrapositive. I'll just write for your convenience. It is based on the contrapositive. So let me take another pen which is visible to you. So this is based on the contrapositive. That is modus tollens is based on the contrapositive. You know P and Q, sorry, P implies Q. At the same time we know negation Q. So what is left now? Only negation P. So conclusion is negation P. So this is modus tollens. Next, laws of syllogism. Please remember the word syllogism. It is similar to your, you should only tell me now. So P to Q, Q to R, we got P to R. So P implies Q, Q implies R, P implies R. It is similar to transitive. So it is nothing but transitive. What is transitive? A is equal to B, B is equal to C, then I can say A is equal to C. Similarly here, P to Q, Q to R, then P to R. So that is nothing but syllogism. So these three are very important and frequently used as we see now, but these three should not have any confusion. What is the first one? Modus ponens. What is modus ponens? I have a statement P, I have P implies Q. When these two are true, then I am left with only Q. So conclusion is Q. Next, P implies Q and negation Q. these two are true, and I am left with only negation P as per the contrapositive, that is going to be true. Next, third one. I have P to Q, P implies Q, then Q implies R, I am left with now P implies R as per the transitive property, and then this is called as a syllogism. Okay. So next, three important one, let us see now. Next one is disjunctive syllogism. What we have seen earlier is a hypothetical syllogism. Another syllogism is also there, which is disjunctive. Disjunction means your R. Okay. So PRQ is true. Negation P is true. Negation P is true. Then I am left with only Q. When PRQ is true, as per the truth table, TT is T, TF is also T, FT is also T, and F and F is a T. So when I have negation P is true and PRQ is true, then I am left with only Q being true. So that's the concept of a disjunctive syllogism. PRQ, negation P, then left with only Q. Next we have disjunction, which is a normal addition property. So we know P statement, then I can write the P as a PRQ, or if I have a Q alone, then also I can write PRQ. So in both the cases, when I have a single statement P, I can write PRQ. That means I can add something else. Or if I have a Q, then also I can talk about PRQ. So it doesn't matter. So you will be getting the result. So when I have only statement P, I can replace with PRQ or vice versa. Next is simplification. When I have P and Q, I can write P or I can also write Q. Both are fine. I can write Q also. So this is simplification. And the last one is conjunction. I have P, I have Q, both are true, then I will be having P and Q. The remaining three, I will not be able to ask you to remember them, but just go through that. So these are all different names, but we may not be using them in our what is called problems, but these are all the other rules of inference available. Maybe complex for you, but you can just go through that, give a glance. But these 6 or 7 are very important. So first three, mode exponents, we have P implies Q, I am left with Q, so solution is Q. Next, modus tollens, contrapositive, I have P implies Q, I have negation P, then I can say negation P is true, or conclusion. Then I have a transitive, which is a syllogism, where I have P implies Q and Q implies R, then I can have P implies R. These three are the important new names. In addition to that, we have 4 more. One is a disjunctive syllogism, where P R Q and negation P, so we are left with Q. Then whenever there is a P, then I can write it as a PRQ, that is a disjunction. Then simplification, which is important again. So P and Q, if I get P and Q, I can conclude it as a P or Q. And the last one, when both P and Q are true, obviously it is a conjunction, P and Q can be true. So these are the 7 important, at least, which you should be remembering. So 2 to 3 times probably if you go through, you will be able to understand that. But there should not be any confusion. Make sure that you are clear with them, and at any point of time, please let me know if I have any confusion, we can discuss further. So next, with this, let us start solving some of the problems. In the exam, you might get problems of variety, and here you can follow a method or a strategy or a step, so that you will not have any confusion while proving this. Okay. So first problem is, test the validity of the following statement. What is the statement now? If I study, I will not fail in the examination. This is one argument. If I study, I will not fail in the examination. Somebody is giving some argument. The second argument, if I do not watch TV, I will study. Third argument, I failed in the examination. So with all these three, what is the conclusion? I must have watched TV. So conclusion is, I must have watched TV. TV. So using these three statements, can we prove that the conclusion is I must have watched TV? So we cannot write the statements and it will be time consuming. So what we'll do now, we give some logical connection or logical representation for them. So use the statements and figure out which are going to be premises. Here I study is a premises, I will fail in the examination is a premises, I am watching TV is a premises. That's it. Three are there. So P, I study, Q, I fail in the examination, R, I watch TV. So these three are being used in a different context. So we are going to use them again here. So with that, the given text can be rewritten as, if I study, I will not fail in the examination. I study is P, I will not fail in the examination is negation Q. If then, so it is an implication. So P implies negation Q. Be careful here. Use your all the logical connectives concept and write them properly. So if you do some mistake here, you will not be able to get the proper result. So P implies negation Q. Next, second one is, if I do not watch TV, I will study. So watching TV is R. I do not means negation R. I will study P. So negation R, then P. Negation R implies P. Then last one is, I failed in the examination. So that is Q. So negation Q. Sorry, I failed in the examination itself is a Q. So Q. So these are the 1, 2, 3. And what is the conclusion? Conclusion is now therefore R. So by using these 1, 2, 3 statements or arguments, we should be able to prove whether this is going to conclude R. What is R? I watch TV. Okay. Now, since we have got the representation in logical form, I will use them. So P implies Q is equal to, just now we have discussed that P implies Q is equivalent to its contrapositive, that is negation Q implies negation P. So I am using the contrapositive here. So negation of negation Q implies negation P, which is equal to, applying the double negation, negation of negation Q is Q implies negation P. So P implies negation Q is replaced as, or is logically equivalent otherwise is to Q implies negation P. Similarly, negation R implies P. Applying contrapositive again, you will get the negation P implies R. Okay. So now, whatever the given text we have, that has been replaced now with this new, that is Q implies negation P implies R, Q. So now try to apply the rules of inference. What is the rules of inference? As I said, you should remember modus ponens, modus tollens, both the syllogisms and some conjunction, disjunction depending upon the context. Now, this is P implies Q, Q implies R. So what is P implies Q, Q implies R? It is a hypothetical syllogism which gives P implies R. So here in this case, Q implies negation P implies R. So I can use that hypothetical syllogism and get Q implies R. So I will conclude now Q implies R is the statement. So by using the first two, I am going to get it as a Q implies R. So I am left with now Q. I have written Q and I have written conclusion, that is R. But we have to prove now. We are just started with this and trying to apply the rules of inference, and at the end we should be able to prove. Now, using the modus ponens, what is modus ponens? Statement P and P implies Q, then I can say it is Q. So same concept, Q implies R, Q, then I can say R is the conclusion. So using the modus ponens, for this R is the conclusion. So we have got R as a conclusion and we are supposed to show R is the conclusion, and both are matching. We can say that the given statement is valid. This is very simple way of proving, but I suggest you to have a step by step process as we see in some of the problems. But you are allowed to do any method of proving, but having a step by step procedure is always what to say, good for you to understand or to keep examiner aware that you know the process. So this is just a way of doing it, but we will see what are the different ways you can solve. But my suggestion or advice would be to follow the step-by-step process. Okay, now we could prove the statement is valid, because question is test whether the validity of the following statement is there or not. So we are going to say it is a valid statement. We should write this. If you don't write, probably you will not be given marks. So valid. Now second problem, prove whether the following argument is valid. In the previous example, they have given a text. From the text we have used English text and converted into logical form. So now they have given logical form directly. It is going to reduce one step for us. So it is given P implies Q, R implies S, P or R concludes Q or S. It is actually one of the rules of reference, but let us not worry about that, but let us prove that using our basic principles of rules of inference. So it's given for us P implies Q, and I said that every argument is used and hence they form the AND operation. So P implies Q and R implies S and P or R. This is the one. So with this we have to prove whether it gives us Q or S. It has become a statement where you should be able to simplify this, nothing else now. So P implies Q, Q implies R, something of that category will help us to get the solution. But let us see how best we can use that. This is very important problem. So P implies Q and R implies S. Now there are two implications here, but implication is missing here. So if you can bring back to the implication, probably we use the reverse process of implication formula. We know the implication P to Q, P implies Q, is written as negation P or Q. So using this concept, can we represent this back to P implies Q? That is what we have done now. So negation P or Q, if we have, probably we can represent that in the P implies Q. The same form we have used and we have represented P or R as a negation P implies R. Okay, fine. Now all the three are in the implication. Now I can try to apply syllogism, because we know syllogism P to Q, Q to R gives R to S. We know P to Q here, Q to R is missing, so not possible. Then we know P to Q, R to S, again totally four different terms. Next one, probably you can see there is a P to R. So one way we have P to Q, R to S and P to R. See if that can be used the way we want. So now we'll use the commutative property and rearrange them. So P to Q and negation P to R and R to S. So now P to Q, Q to R. So just using the property of commutative, we could able to get a solution for the syllogism problem. So probably we can apply syllogism, and P implies R, R implies S. As per syllogism, we will get negation P implies S. So we have already P implies Q and negation P implies S. Now we also know that now here again which inference formula to be used, there is no sync at all here. So probably we have to find some other solution. Now we will go to the contrapositive equivalence of P implies Q, because we know that there is a negation P and here also there is a negation P possibility. If you go to contrapositive, we will try that. So contrapositive of P implies Q is negation Q implies negation P and negation P implies S. Again I can bring back the syllogism concept. So P implies Q and Q implies R, I can get P implies R. So negation Q implies S. So what we have to prove? We have to prove Q R S, but I have something implied. So I know that there is a relation between implication and R symbol. So using this, I will bring back negation Q implies S to Q R S. So this is how it is proved now. So every time we are going to write the names of the inference rules that is being used. So this is what I said, we should remember the names also, so that we will be able to write them properly. It's not a big one, so just 3-4 times if you practice, these names are going to be with you. Next, third problem, show that the following argument is valid. So negation P or negation Q implies R and S, R implies T, negation T, so we conclude it is a P. So same format, so negation P or negation Q implies R and S, and R implies T, and negation T. So we have to see where we can conclude. So there are so many negations, probably like inverse law in laws of logic. Here also modus tollens is the one which deals with the negation. So look if that can be applied. Okay, so here in the last one we know that it is similar to P to Q and negation Q, so probably you will get negation R. If you look at the modus tollens says, which is based on the contrapositive, P to Q, negation Q, then we are left with negation P. So this is what we got now. So this is similar to that level, and using modus tollens we will get negation R. So once negation R comes, using disjunction, we know that if there is P, I can write P or Q. So what is Q here? Use suitably, whichever is going to help you. So you can write either R or Q or P. In this case, there is some relation I can see here, so probably you can use either of them. So let me use negation S. So negation R or negation S using the disjunction property. Now, since both negations are there, I can apply De Morgan's theorem and I can remove the negation outside, and I can make negation R and S. Okay, here also there is R and S, here also there is R and S. Probably you can find some solution. What is the solution now? It is like P implies Q and negation Q, similar to modus tollens. So P implies Q, negation Q, so will give me negation P. So what is negation P? Negation of negation P or negation Q, this part. So now again applying De Morgan's theorem, we will get P and Q, and applying the simplification, P and Q will give us either P or Q. So it is required to prove it is P, so let me use P as a conclusion, and I can prove that we have got P out of this. Thereby we can say the given argument is valid. I mean, rather there are 3 arguments, the given arguments actually, the given arguments are valid, or the given conclusion is valid. That is a fair enough process. We can say the given conclusion is a valid conclusion. Okay, next one, establish the validity of the following argument. So they can ask anything, but finally we have to check whether the given arguments are valid or not by applying various rules of inference. Now Q or negation R or S, negation Q or R and negation Q concludes or implies yes. So again, given that Q or negation R or S and negation Q or R and negation Q. So we have to observe first whether it is going to give some meaningful inference, so that we can apply the data. Otherwise we have to bring it to the some of the formula. So majorly if you look at modus tollens is used, syllogism is used majorly. So later simplification, disjunction, conjunction will follow. Now Q or negation R or S and this looks like a or B intersection C. So we can apply our distributive law and distribute them A union B intersection C type, or A or B and C. So if you do that, you will be getting negation Q or R and negation Q or negation Q. Always be careful with the parenthesis grouping. If you miss the grouping, probably you will not be able to get the proper solution. So Q or negation R or S is retained as it is, and this part negation Q or R and negation Q. So probably if you remember the concept of what you call absorption. In fact, I have written 2 extra steps here, we can avoid them. So if you look at the absorption is what? P or Q and P. P or Q and Q will give me P only. So that is absorption rule. So by applying that, I will get these two, you can avoid actually. This is a repetitive rule. So directly I can get the by absorption some negation Q, which is final result. Now we have got this compound result. Now see how best. So this, since we have same operators, I can group the way I want using our associative property. So with that, I am going to group like this: Q R, negation R or S, and negation Q. So now we know that as per the syllogism of disjunctive syllogism, where we have a P or Q, P or Q and negation P, P or Q and negation P will give us the negation, I mean the Q or Q and negation Q. So I'm just rearranging them so the way it is going to be. So P or Q and negation Q will give us the only P. So what is the P here? Negation R or S. So this I have rearranged using associative property and applying disjunctive syllogism. What is disjunctive syllogism? P or Q and negation Q. So I will be left with only P. So what is P here? Negation R Vs. But what we are supposed to prove? We are supposed to prove in the conditional form, and we know there is a relation between R operator and conditional. Using this, probably we can represent negation R or S as R implies S. Thereby the conclusion is a valid conclusion. So always you may not be getting a valid conclusion. Sometimes you might get invalid as well, but you should be careful. So when you will say a conclusion is invalid, probably the arguments are not able to be solved at all. We cannot apply any of these inference rules. Probably we can say the valid is going to be invalid. Okay. Next, prove the following argument. Okay. Now again text is brought here. So Geeta is baking a cake. That is first one. If Geeta is baking a cake, then she is not practicing her flute. Second, if Geeta is not practicing her flute, then her father will not buy her a car. Third one, these three are going to conclude Geeta's father will not buy her car. This is a conclusion. Now, as usual, represent them as a normal statement so that we can use the logical statements for them for solving. So PQR. So representing given statements in the form of P. First one is P. Second one is P implies negation Q. Third one is negation Q implies negation R. The conclusion is negation R. So by applying this, so we know that P implies Q and Q implies R will give P implies R directly. So we apply the syllogism, will get P implies negation R directly. So we are left with now P and P implies negation R, that is negation R. Again by using mod exponents. What is mod exponents? P to Q and P will give me Q. So in this, Q is nothing but negation R. So negation R is what we are getting. Negation R is what we are going to prove. Thereby we can say the argument is proved. Again I suggest to use a step-by-step procedure, because this is not a step-by-step procedure. So if you are comfortable, you can go ahead. Otherwise, we can use step-by-step procedure. Means step 1, step 2, step 3, where you write premises every time and write on the third column as per the table what is the name being used. Okay. So probably you can see one of such examples so that you will not find difficult. Okay. Now let us take one more example. So P implies R, R implies S, T R negation S, negation T R U. Negation U finally gives us negation P. So many. So this is what? Give numbers like this for your convenience. Okay. Now, so from 1 and 2, what is 1 and 2? P to Q, Q to R. Using syllogism, you will get P to S. So 1 and 2 have been reduced to P to S. Next, third one is what? Negation S or T. So using commutative property, we have rearranged them. So negation S or T. Since we have P implies S here and R symbol here, probably we know the relation between R and implies. So using that we can write this S implies T. So we know that P implies S and S implies T. Probably by syllogism again we get P implies T. So with this we have done statement 1, statement 2, statement 3. We get P implies T. We are left with now statement 4 and 5. So what is the 4 and 5? Negation T or U. So negation T or U again I can represent using P implies Q is equal to negation P or Q format. It becomes T or Q. So I know P or T, P implies T, T implies U. I can get P implies U. So next we have P implies U and negation U. So negation U means modest tollens, which gives as negation P, contrapositive. So negation P is the result. This is what we are supposed to prove and we could prove. This is maybe a step-by-step process for you to write the given result is valid or not. So we should write the result is valid, because don't forget to write at the end whether the given statement is valid or not. Okay, next one more we let us see. So P to R, P implies R, negation P implies Q, Q implies S. We have to prove whether negation R implies S. So given P implies R, Q implies negation P implies Q, Q implies S. So first step is P to R, given already. Second step is P to R. So I can write P to R as negation R or P, because why you should write? First you see, if you have P to R, then something like R to Q, then I can write syllogism. There is nothing of that category here. Or by commutative law, if you can interchange, that is also not possible. So thereby you try to find various ways. So P to R, if I apply, probably I may get negation P. So when I get negation P, I may use that syllogism property. So it's just by observation you will be able to make out. So by contrapositive, we know that P implies R is equal to negation R implies negation P. So by writing that using syllogism, I can say negation P implies Q and negation P implies R. So negation R implies Q. So I'm just using the formula. What is the property? First one is negation R implies P. Then we have a negation P implies Q. So P to Q, Q to R. So negation R implies Q by using 2 and 3. So I'm done with this and this now. Now I'm left with Q to S. Again by applying syllogism, P to Q, Q to R, I can get negation R implies S. But what we are supposed to prove? Negation R implies S. We already got it, thereby we can say the argument is valid. This is what I was talking about as a step-by-step process. You should write 1, 2, 3, 4, 5, 6, use them as they are, and write on the right hand side what rule of inference is being used. Thereby you will not have any confusion. Even the examiner will make sure that you have followed the process and you have used the proper inference rules. Okay, so next we have some of the problems probably which you can try your hand, and same process we can imply, and they are all checked and probably you can get. And here some of the arguments I have given which are going to give invalid statements also. Probably you can try them. Okay, so I will leave these problems to you so that you can try and understand the concept of rules of inference better. Okay, thank you.